Now, before I describe for you how the technology works, I'd like to share with you how we estimated the value of this technology. And the value of this technology is primarily in the reduction of energy required to run the system. You can see the calculations here. I'd like to point out that these are industry-accepted calculations, and there's plenty of good references to which I can refer you to learn more about how these are done. My personal favorite is from the Institute of Clean Air Companies. There are also several very good calculators by which you can input your data, and they will calculate the estimated amount of energy required to run the RTO. There's one from the EPA, from Cyclotherm, and another from Captis Aire. But all these sources use the same basic calculation, and they use one central factor. That's the specific heat of air. The specific heat of air is the number of BTUs required to heat 1 pound of air by 1 degree Fahrenheit. And that's how we did our calculations. I won't go through these in great detail, but we used the specific heat of air along with the amount of air going through the system, the density of the air, and the temperature increase in the device. We also considered the energy efficiency of the RTO, which is actually a very efficient device. However, there are heat losses. Some of the heat goes out the stack. Some of the heat is lost by radiant heat losses through the surface of the RTO. And this is the heat that we have to pay to replace. We also considered and subtracted from the amount of energy provided by the very emissions that are being oxidized. So in this example, we're oxidizing terpenes, which have a lot of energy. So we subtracted this terpenes energy from the amount of natural gas required to run the system. We crunched all these numbers and found that this system would use about 227,000 MMBTUs per year of natural gas. We can then calculate the annual cost per year. We could use today's value of about 2 or 250 per MMBTU. But if you're at the point where you're considering buying a device that's going to last you 20 years or more, you might want to think about what's your long-term outlook on the price of natural gas. Hopefully your financial guy can tell you his perspective. In this particular example, we estimated the long-term cost of natural gas at about $3.50 per MMBTU. This equates to about $800,000 a year in natural gas, and this is what we can avoid by using the FBC. Now we've calculated the amount of natural gas we're avoiding, we can also calculate from that the amount of greenhouse gas emissions that we're avoiding. In this case, about 12,000 metric tons per year of greenhouse gas emissions. And if we can sell these carbon offsets for $5 a ton, that equates to $60,000 a year for carbon offsets. I'll talk more about carbon offsets in my next slide. Another way that we can reduce energy is by reducing the amount of electricity required to run the system. And that's primarily because we use less fan power to move the air through the system. So reducing the overall horsepower of the system by 1,000 horsepower equates to approximately $400,000 a year in electrical savings. Finally, if you're recovering terpenes, you can sell these. The value, of course, depends on your yield and the price per gallon. But we know that there's about 1 gallon of terpenes in every oven dry ton of wood. So for a pellet mill that's producing 300,000 tons per year of pellets, that has this 1 gallon of terpenes per oven dry ton of pellets, and if we get a 75% yield, that equates to about 225,000 gallons per year of terpenes. At $3 a gallon, this equates to $675,000 a year for selling terpenes. Now, beyond this, there could be some additional savings in avoiding repairs to those large, heavy moving parts. But this should give you a much better idea of how we've estimated the value of switching to the FBC. We've also been speaking with Climco, an American carbon registry, about the value of the greenhouse gas emissions reduction. And what we're learning is that it may be possible to register and verify a project for a site that's switching to the FBC and thus reducing greenhouse gas emissions, or carbon offsets. Each carbon offset is equal to 1 ton of CO2, and these offsets can be sold on exchanges. Now, there's a wide variety in pricing, and you can estimate the value of the offsets based on carbon allowances, which you can see on the International Carbon Action Partnership website. But in speaking with American Carbon Registry, they estimated the value of our offsets at about $5 per ton, which in this example equates to about $60,000 per year for selling carbon offsets.